Imagine a vessel, not just a submarine but a ship, that can withstand the crushing pressures of the deepest ocean trenches, yet is also the most sophisticated quantum computer ever built. Think of it as a sub that grew up reading sci-fi and took notes, a hull that isn't just a shell, but an active, intelligent sensor array. We're talking about the theoretical Nautilus X and its diamond quasi-crystal hull. This isn't just about surviving the deep, it's about pioneering the future of mobility. The extreme physics we're about to explore is the foundational blueprint for a vessel that could eventually generate the stable fields necessary for things like warp speed or even time travel by creating a perfect, stable quantum bubble around itself. No flux capacitor required, probably. We're diving into expert analysis on a technology that will redefine what a hull can be, from the atomic structure of diamond to dynamic aperiodic quantum memory. It's complex, it's mind-bending, and it's happening now in labs around the world, where coffee is strong and equations are stronger. But first, a challenge. If you want to see more content that bridges theoretical physics with bleeding-edge engineering, hit that subscribe button and turn on notifications. Your support literally helps us build these concepts in the digital realm, one improbable idea at a time. The core of the Nautilus X isn't steel or titanium, it's synthetic single-crystal diamond, SCD. Why? Diamond is the toughest material known, easily capable of handling the 5 GPa plus pressures of the abyssal zone. Also, it outblings titanium by several orders of magnitude. But its true value is its dual purpose. It's a structural material and a perfect quantum host. We're talking about nitrogen vacancy, or NV centers, a tiny defect where a nitrogen atom sits next to a vacant spot in the diamond's carbon lattice. These defects are essentially isolated quantum systems that remain stable even at room temperature. By embedding millions of these NV centers into the diamond hull, the entire shell becomes an integrated quantum sensing network. Basically, the ship grows nerves. This IQSN does 3 incredible things. Besides making jewelers slightly nervous, quantum manometry, the NV centers are hypersensitive to mechanical strain. Any tiny flex in the hull from pressure is detected and quantified with an unprecedented resolution of up to 0.3 megapascals per root hertz, turning the entire hull into a pressure sensor, basically a Fitbit for ships. Stealth navigation. It acts as a superior magnetometer, mapping the Earth's local magnetic field with sub-nano Tesla precision. This provides high-precision positioning, navigation, and timing without any external emissions, achieving absolute signature dominance, the naval equivalent of ninja mode. Future coherence. Most critically, the inherent stability and purity of the carbon-12 diamond lattice are essential for maintaining the fragile spin coherence, T2, of these quantum systems. That coherence, the ability to keep quantum information intact, lets the system hold its breath longer than I do at the gym, and it's the prerequisite for sustaining a protective quantum bubble for faster than light dreams. Now for the truly mind-bending part, the quasi-crystal. We're not talking about static materials here. We're talking about a dynamically generated quantum phase of matter called a discrete-time quasi-crystal, or DTQC. Traditional crystals have a repeating, symmetrical structure. Quasi-crystals have a long-range, ordered pattern, but it's non-repeating, aperiodic, like an infinite tiling pattern. Imagine a dance routine that never loops but still stays on beat. Researchers fabricate this DTQC inside the diamond's NV spin ensemble by hitting it with a quasi-periodic, non-repeating sequence of microwave pulses. This dynamic phase acts as a quantum analog of RAM. It can store quantum memory over extended periods without losing energy, essentially ticking indefinitely. Translation: no spinning beach ball of doom. This is the computational engine. The structural diamond is the platform, and the dynamic DTQC is the intelligence. It's a hybrid quantum architecture, a diamond hull that is not only a structural element, but is simultaneously its own fault-tolerant, self-monitoring quantum computer. Tough on the outside, nerd on the inside. So, what keeps this incredible ship on the drawing board? Two main challenges: scaling and shielding. First, material scaling. We need to go from 5 square millimeters lab samples to structural plates spanning square meters. Think postcard to pool table. The process, whether HPHT or CVD, must be perfected to maintain extreme isotopic purity and uniform NV center distribution. Second, environmental resilience. The Nautilus X would likely use a high-power system, perhaps a magneto-hydrodynamic drive. This drive generates massive magnetic and electric fields. These fields create Zeeman and Stark effects that would instantly destroy the fragile quantum coherence of the NV centers. It's like parking next to a magnet star and hoping your compass still likes you. The solution is an unprecedented shielding system, a multi-layered approach of passive, high permeability materials like supermalloy, coupled with an active compensation network. The NV sensors themselves act as real-time magnetometers, feeding data back to the compensation coils to dynamically cancel the drive's noise, stabilizing the internal magnetic field to a tolerance of less than 0.1 nanotesla. In short, noise-canceling headphones, but for physics. Only with this stability can the hull's quantum systems function, making the sensor hull absolutely critical to the ship's operation. The diamond quasi-crystal hull isn't just about building a stronger ship. It's about designing a stable, quantum-cohesive environment that can bridge the vast difference between the macro world of structural engineering and the micro world of quantum physics. First step toward the kind of active, stable field generation required for truly revolutionary propulsion, whether it's deep-sea covert travel or leaping across the stars. Ambitious? Absolutely. Impossible? Ask tomorrow. The pursuit of this absolute integrity reminds me of an old parable. Here is the parable. A master artisan builds a traveling chest. He spends weeks on the unseen parts, planing the inside panels, sealing every pore, tuning each joint until the lid closes with a whisper and the air inside stays still. From the outside, it looks ordinary, but when storms come, the contents remain dry, undisturbed, and precisely where they were placed. The lesson is simple. Integrity, you cannot see, governs everything you can. For Nautilus X, the polished interior is coherence, quiet magnetic fields, low-phase noise, and stabilized spins. Only when the inside is perfectly calm can the outside survive chaos and move with purpose through it. The Nautilus X hull is that chest. Its hidden quantum integrity, though unseen, dictates its entire operational success and its ability to achieve signature dominance. Like any masterpiece, the shine outside is nice, the genius inside is everything. The future of naval and space exploration depends on this internal perfection. We've only scratched the surface of the TRL roadmap, the thermal management, and the bonding challenges involved in this incredible project. If you found this exploration into quantum engineering and material science fascinating, please do two things. Hit the like button to signal that you want more deep dives into theoretical science. Our editor's coffee supply depends on it. Leave a comment below and tell us, what do you think is the biggest hurdle to achieving a full-scale diamond hull? Is it the megawatt power, the scaling, or the magnetic shielding? Brave takes welcome. Thank you so much for watching and for being part of this community that looks not just at what is, but what could be. Stay curious, stay kind to your qubits, and we'll see you next time.